same here. Okay, so ladies and gentlemen, just while I'm preparing this, I'm hoping that you could go and close the model that with which we've been dealing. Okay, so in order to close it, in order to close the model which we've opened, there's two ways to do it. You can do right-click on it, and you can say close. If it asks you whether to save it or not, I would advise against saving unless you have made a set of changes that interest you. I'd like you to be in a situation where you have nothing open so that we have a canvas upon which we can write large. Okay, now, ladies and gentlemen, we're going to explore a few elements here of the AnyLogic modeling vocabulary. Okay, and this vocabulary is a fairly broad one. In contrast to something like system dynamics modeling, a tradition with which some of you folks are familiar, where you have stocks and flows and some things that are variants on those. Here we actually have a lot of pieces out of which we build these models. A lot of pieces that collectively describe these processes that the models are characterizing. A key one of them that we're going to be exploring now is parameters. We use this to capture aspects of heterogeneity. Those situations where the tail wags the dog, we want to capture heterogeneity because a subgroup of the population is of a particular interest, or we want to tailor our interventions for those with certain characteristics to be different. For example, dealing with children at risk of different ages, we want to be interacting with them differently, or maybe we want to have outputs that describe the effectiveness for agents of different ages, much like we would with a study, to have study outcomes summarized by age. But we're also going to have a number of other mechanisms. We're going to be exploring populations within this model, and the graphical interface associated with it to display. We're going to have spatial embedding. We're not going to have agents move around, but they're going to be embedded in space. And in later models, some this afternoon, for example, we will have transitions between what are called state and within state charts and other components. But we're going to start with our basics, capturing heterogeneity. Heterogeneity is one of the big motivations for using agent-based models, because if we try to capture heterogeneity in an aggregate model, we find it becoming unwieldy. With too many aspects of heterogeneity, it kind of blows up. If we have to distinguish men from women, the model size is doubled, for example. Not so with an agent-based model. We just add a characteristic to each agent, and we can maintain the model size without it getting too much larger. So, ladies and gentlemen, I'd asked you to close this model here in AnyLogic. I would like to take a first baby step, a small step for each of you, but a big step, a giant leap for your foray into agent-based modeling and system science. And so I'd like you to do File, New, and choose Model. Oop. There we go. And I'd like you to choose a model that's called Simple Heterogeneity. Okay? Now, when you're presented with this screen asking about a new model, you'll notice that it's also asking about some other things. Most of them are a little bit immaterial. You don't need to really worry about it that much. Occasionally, we'll deal with changing the so-called package name from its default. 98% of the time, it's the same. Occasionally, we change it to avoid a clash with another one we've already built. The model time units is something of greater concern. Without lots of generality, I'm going to choose this to be in years. Now, an important thing to understand here, a point to which we'll come back. Time in any logic is by default continuous. What that means is things happen as quickly as they need to or as slowly as they need to. And when we say model time unit, it's not to say model time step. It's not like here things jump forward on a year-by-year basis. It's instead just what's our meter stick or yardstick for measuring time? What does one time unit mean? In this case, it means a year. Okay? And that's important because it's keeping track of this calendar for us, for example. And it needs to know if we say a person is in this state of for example, acute HIV infection for a period of 30 time units. What is that time unit? Is it days? Is it years? It makes a big difference in terms of sort of the speed with which things play out in calendar time. So we're going to say it's years without lots of generality. The truth is, this model is actually not going to be exhibiting interesting dynamics. We're capturing heterogeneity here. After a break, another break, we will then start to capture dynamics. Well, and then the issue of time units will be very, very important. Right here, it's a little bit immaterial. Okay, so ladies and gentlemen, I have called up the projects here. Now, I'm going to have to ask your apology early and ask your apology often, because I'm using what's called the Linux version of AnyLogic. And the Linux version of AnyLogic is not as well supported as the Windows or Mac version. And it has this extra feature or bug of this palette which shows up beside the window. In your models, you should see a palette. Do you see a thing called palette here? This is the set of paints that you'll be dabbling onto the canvas to build up your model. These are the pieces out of which your model can be composed. This little thing up here just provides a way of easily navigating the palette. I don't think you have that in your versions. And that's okay, because in mine it's half broken. It sort of covers things, and I have to navigate around it. It's a most unpleasant intrusion. But you'll see me sometimes navigating around it. Don't worry that you don't have it. You're lucky. It's not foisted upon you. Okay, so ladies and gentlemen, we created a new model. There's the name of the model. And you'll notice it created one thing in the model, something called main. Okay, the main represents the global environment, the sort of overall context for the model, the stage in which the agents strut. There may be many agents in the model, but there's only going to be one main. Okay, one main. You'll notice it also gives us a kind of default scenario to run. Right now, it's not all that interesting, but we'll have lots of little options we can change later, including how long it runs, on what calendar date it starts, which non-coincidentally is today. Okay, ladies and gentlemen, we would like to now paint a beautiful canvas, a beautiful picture on our canvas, okay? We're going to actually go and start to build up a model. So in order to build up a model in agent-based modeling, we need agents. We need to describe agenthood, agentness for our model, okay? In this case, there's only one type of agent. It's going to be a person agent, okay? And we're going to add that to the model. And there's going to be a population of people. Just like there was for that first model, we had a group of the synthetic population of people who moved around in the streets of Melbourne. You remember that? And here, we're going to have a similar thing. We're going to have a population of people. But in order to have that, we need to define what is personhood for this model. So we're going to right-click on this model and say New Agent Type. How did I do that? I right-clicked on the model. I said New Agent Type. and you can say person. Now, by convention, we put a capital P for person because it defines personhood, personness. It defines the nature of being a person with respect to this model. Remember that models are abstractions. They're like maps. Each model hides some detail, reveals others. Depending on the purpose of the model, we'll capture certain details and not others. In this case, we're describing people, and we'll capture some details of them and hide others, as we'll see. So I call it capital P. It represents personhood, okay? And you could say next. You could actually pick a little image for them, but I'm not going to do that now. I'm just going to say finish. And what you'll see happen is to the model gets added this new thing, which I argued before is an agent. You notice the Da Vincian logo next to them. This is indicating that they are present as an agent within the model. I won't get into it, but it turns out main is an agent. It just is a special agent. There's only one of them for the model. Person here is an agent. So this is going to reflect personhood. We put a theory of what it means to be a person in this model into here. This includes their state, sort of their current situation, how they evolve over time, their characteristics that don't change, things like their sex, for example, things like their ethnicity. We would put these in here. But let's first give them a face upon the world. Shall we not? Hearing no objections, I'm going to go to the palette, and I'm going to choose from the palette this area here. You'll notice there's this thing called presentation. Look at that, students. That little palette thing disappeared. Maybe that gives me a... Oh, no, did it? Uh-oh, it just relocated. Okay, that's lousy. Okay, so I'm going to drag in an oval, and we'll put it in the upper left there. But more than that, ladies and gentlemen, I'm going to resize it. And there's how did I do that? I went to this palette thing. It looks like a bunch of platonic shapes. And I went and I selected oval, and I dragged it over here. I'm not going to drag two of them because I only want one. Okay. Ladies and gentlemen, I have an oval now, and that oval is placed in person. Put it in person, because it's an aspect of their face upon the world, not main's face. Person. Be sure one of the most common rookie mistakes is to put the thing you're adding to the wrong agent. We don't want it to add it to main. Main is going to hold things like a count of the number of men and women, or the count of the average income in the population. This is going to be, we want each person to have be described by a face, okay? And here I'm doing it with an oval. Now you can engage in frobbing behavior like this and grow it or shrink it, but I'll show you a nicer way, a way I consider nicer. If you select it, you go over to the properties window and you can set its radius as at your pleasure. So I'm going to set its radius to be let's say 10. Oops, not 19, 10. There we go. 10, ladies and gentlemen. 10, I tell you. We'll come back to that. We'll make it more flexible yet. 10, there we go. Ladies and gentlemen, this is our person. Now, the fact that I defined their characteristics like this is not an accident, the fact that I did that first. You might say, well, where's the logic here? Well, I'm going to be adding logic. Don't worry about that. Soon enough. But the reason I added this is because if you add it before adding the population of these people into the model, it'll save you some grief. You can do it after that, but then you have to go through a little ritual and press a button and tell it to regenerate the picture, and it's kind of a pain. So it's better to add any visualization you have early. Having done that, this is describing our theory of personhood. Our theory of personhood is particularly impoverished, or shall we say stylized. The theory of personhood is that people are circles. Now, that's okay. We can take solace, because there's many theories in physics that start with approximating a cow by a sphere or something like that. You know, say, okay, assume a spherical cow, or a person by a rod. But here we're going to characterize a person as a circle for the moment. It's going to get more interesting than that. But there we go. We'll soon enough have pictures of people of various sorts, and you can embellish them to your pleasure. Okay, so there we go. Ladies and gentlemen, we have this theory of personhood, but we're going to elaborate. But first, we're going to add a population of these people. Right now, there's just the theory of personhood. If we go to Maine, there ain't nothing there, to use the vernacular of our southern neighbor. Yes, question? Oh, thank you, Aiden. The center matters. The U.S. seems to have forgotten that principle, but the center matters. So this, it'll be favorable to locate this circle over this apparent origin. In fact, it is an origin. What that will mean, thank you, Aiden. What that will mean is that the logical position of the agent will be the same as their visual position. And that's useful sometimes for figuring out why things look weird in the model and so on. You'll be able to track, oh, it's the agent at this location. If you put this offset by a certain amount, they're logical. Like, let's suppose you move this to the right. You know, if I were to do this, don't do this, especially don't do it at home. But if you were to move this out here, then their apparent location will be shifted to the right of their actual location, and it might get you confused. So I don't want to do that. We want to minimize confusion here. Okay, so I put it at this origin here. Okay. Now, any question about that? So we have a theory of personhood, but thus far, we lack the vitality of a population of people. All we have is the theory of personhood. We say, there was displeasure encountered in the audio visual system. I'm not sure why, and I am Christine. There is computational dysfunction that. Okay. Everything suddenly shut down. Yeah, well, I see you're out there, and we'll get their break soon enough. Yeah, hopefully before they break. It came back. It's not the first time it's occurred with computers. Thank you, Christine. Okay, so ladies and gentlemen, we have only a theory of personhood. Now we need to add a population of people. Oh, wow, Christine? It's kind of like the snuffleupagus. You leave the room and it goes bad. Yeah. Okay. Okay. Yeah, that's great. He could sit in the back. Okay, ladies and gentlemen. So we're going to add a population of people. All we have is a theory of personhood. A person is described by a circle. But we're going to be adding more texture to that. But let's add a population of people. Where does a population of people live, do you think, in the model? It would live in Maine, it turns out, because that's the overall environment. That's the context. So populations are going to live in Maine. You might have several populations of people. A population of say, people who are distinguished by this feature, and another one of people distinguished by this other feature, maybe doctors and patients, for example. But for now, we're just going to have one population of people. So ladies and gentlemen, we're going to open up Maine, and we're going to add this population to that. How do I add that population of people to that? I drag from the agent class called person, and describes a class of people, and I drag it to Maine. And you notice it prompts me for a name on it. I'm going to say population. Alternatively, if you forget to do that, you can click on it and you could say population. and I'm going to change it to be population of agents. So how did I do that? I said not a single agent, it's a population. And I'm going to say leave it as 100 for now. We'll come back to that. Ladies and gentlemen, what have we done? What hath we wrought? We've added now not just provided a theory of personhood that is stylized in the extreme. We have further added a population of these people of size what? Anyone? Size 100 indeed. Ladies and gentlemen, it's a good practice to build early, build often. See this little thing up here? It says build model. If you press that, it should say build completed successfully. That's a sign of a happy model. Okay? And a happy model is a happy modeler. Okay? And the more frequently you do that, the sooner you'll spot an error, and the less question you'll have about where it came from, because you've only added one or two things. You know, where did that come from? Whence did that come? Which allows you to resolve it more quickly. Okay? Same principle with running the model. If you run it frequently, you may see some weird behavior, and you'll know, oh, that's interesting. So that came from this particular thing. Where if you go hours and only then run it, you might not be sure what particular thing you added came into it. Okay, so let's run this experiment. I said simulation, run, and oh, well, what's going on? You see a little thing there. Oh, there's a population. If you click on it, it says 100 agents. Look at that. You go down, and we can actually see each person in the population. It's running out. Look at that, 16, 17 years pass. You're running it out, and you're viewing each person, but each person is singularly similar. They're a circle, ladies and gentlemen, a circle. So years are passing, empires rise and fall, but the population remains a set of circles. But they're singularly uninteresting because they all occupy the same place. They're all sitting there, if you noticed, they're all sitting there in the upper left. Did you see that? You can do a right click and drag. There they are. They're sitting atop each other like cordwood. Okay. So let's lend them the dignity of their own location, their own place in life. Shall we not? Okay, hearing no objection. I am going to go to main and click on the population. Ladies and gentlemen, we could actually add where they go in two different ways. Here we're going to do it in the population. Okay, this is the most flexible and most general way. It'll capture open populations when people come in due to immigration or birth. This will accommodate that. So you notice with the population, it says something of relevance. You see it says initial location? You see that? Say, we can go and we can say in the specified point. And this allows us to say where this agent should go, whither they shall go. Ladies and gentlemen, this is a place where we could use this distribution picker if we wish to do so. We could draw their location, for example, from a beta distribution or a uniform distribution. We could draw it, for example, from a normal distribution. You could choose any. I'm going to, right now, choose it according to a uniform distribution. Unless, I mean, do people really want to see one of the others? You want to see something? Okay. I'm going to say uniform. I'm going to say uniform. This is just like typing a formula in Excel. We're giving what's called a Java expression. It's a formula. And we're going to say it's between 0.0 and 500.0. Okay? I happen to know the windows have size 500. And I'm going to say the same thing for y. So this is saying, okay, for their x value, draw a number from this uniform. So when I need their x, run this thing, and it's going to draw a number from a uniform distribution, meaning 0 and 500 continuous. And same thing for y. Do you see that? Okay. Ladies and gentlemen, this is uniform. Now, I fear that this is too small for you. Would people like me to grow this in size? I could try to, during the break, I'll try to grow the font so it's large. What I could also do, with a nod to our LA neighbors close to Hollywood, I could create a big screen. Here we go. There we are. We'll put it up on the big screen. Okay? There we go. This is what I put in. Okay? Okay. It's unlikely to be a blockbuster box office film, but it serves its purpose. Okay? Okay. Okay, ladies and gentlemen, shall we run it? Let's build first. Who needs more time? Who needs TA help? The TAs stand ready. Okay? Okay. Okay, here we go. We're going to build first. Make sure it's a happy camper. You'll notice that I didn't put semicolons. Semicolons will be your bane sometimes. Semicolon is told when you need a command to do something. This is just, it's a formula. It's something that's drawing a number. It's computing a number. So no semicolons are needed here. It's just saying, draw it from this uniform distribution. And I'd like you to run it now. I pressed build, and it was happy. There we go. There, ladies and gentlemen, is our first model. What are we looking at? What are we looking? Anyone? We have 100 people in the population. You can see them listed there, although their names are uninspiring. Where are those people located? Yeah, so it's 0 to 500, and their location is uniformly distributed here. By contrast, you know, if we were to, for example, say, okay, we want their location in the x-coordinate to be drawn from 0 to 200, and the other at 0 to 500, what would happen? What would happen if I said this? Yeah, it'll be narrower. Yeah, it'll be wide. I mean, it'd be narrow, but still long. There we go. See that? So here we're assigning them characteristics according to these formulas. And I'm going to say 0 to 500, okay? Ladies and gentlemen. Okay, TAs, prepare to muster. Deployment is imminent, I think. Wade is doing double time. We need help for him. Okay? Help? Okay. It's either a good sign or they're beyond help. Okay, ladies and gentlemen. We're going to modify this model to be more interesting. Right now we have heterogeneity in one thing. What's that thing? Begins with L. Location. Location. Let's go add some additional elements of heterogeneity. Right now, the theory of personhood is stylized in the extreme. Let's give each person an age, shall we not? Okay. So, ladies and gentlemen, this is going to be a point of considerable significance. This is going to add one of the key elements of any logic, one of the key components of that toolbox of any logic flows. And unfortunately, I closed here, but it's this alphabet of any logic. It's called a parameter. So we're going to go to person, and we're going to go to the palette, and we're going to go to the agent area of the palette. Before we were at the presentation area, that gave us these nice shapes. Here we go to the agent area, and we are going to drag in what's called a parameter. How did I do that? I went and I selected this, and I dragged this parameter right down here into person. And I'm going to say its name is age. if you dragged it in, you didn't name it in time. It got there and you didn't name it. You can always go select it and change its name up here. Okay? Yes. Sorry? Oh, okay. Help? Who needs help? Who needs help? Okay, help needed, sector 2. Row 2. Who else needs help? Okay, ladies and gentlemen, we've just lent each individual an age. Yes, Carrie? They went off inexplicably several times, but at the moment they seem to be stabilized. They went off spontaneously and in short succession. Yeah, yeah. No obvious trigger condition.
Rob said if it happens,
yeah,
you can shut off the display and turn it back on to try it.
Yeah.
But he noticed it this morning as well.
He did.
But if it's good now, we'll leave it for now.
Okay. Thank you. Okay, ladies and gentlemen, did people add age? Okay, now what I'd like to do is I'd like to go back and I'd like to go to main and go back to the population of people. You'll notice each population member now, in addition to specifying the number of agents in that population, we have something else. What is that thing we also have? Age. For each person in the population, we have to give it a way of determining what their age is. You know, what age should be assigned to them. When we added that parameter age, it actually asked us, you probably didn't notice, but in person, it asked us for a default. That default is just, if we don't go specify it here, which one to provide. But generally speaking, you don't just want to use the default. It would just provide that as kind of the default in this interface. So for their age, I'm going to draw their age between 0 and 85. I'm going to draw it from a uniform. We're going to come to custom distributions in a little bit, but for simplicity, it's going to be between 0 and 85. Are we okay with that? Okay. So, ladies and gentlemen, build early, build often. Go up next to this button that says Run. Press Build. It will say Build completed successfully. It should. If it doesn't, summon a TA, post-haste. Okay? Okay. The TA scan, vigilant. Okay, I'd like you to now run the model. If it's a happy camper, now you can run it. And you don't see anything different. What do we have to do to see what's going on at the agent level? Who could tell me whither to go? Yeah, don't say anything too rude about where I should go. Sorry? Yeah. There are ways at AnyLogic we'll see where you click on one of them and it will show its information. But those have to be specified. We go up here, ladies and gentlemen, to this navigation menu, and you drag down to population. And you can click up in the population, and you'll see each of the agents. You can scroll through. This is agent 7, 8, 9, 10. The first one is agent 0, because we are in a department of computer science. And much to mathematicians' chagrin, we start things with 0. Ladies and gentlemen, here you'll notice we have people in the population, each has a different age. Let's show that in their representation. What could we do that would show their age in their visual representation? How could we capture in their visual representation an age? What could we do? If they're older, we make them what? Larger. Good. Now, we could also, it's not a trivial question, like we could make them more to the right, in other words, place their location based on it, based on age. But here, why don't we affect it in terms of size, okay? So I'm going to go up. So you have to be careful here. I want to change how a person's size is determined. How would I do that? How did I determine that circle? How did I set what size that should be? Does anyone remember? Yeah, I set the radius. Where did that circle live? Where is it? It's easy to think, oh, it's here in Maine, but this is actually just an indication that this population has this appearance. So this is a chimera. This is a sort of an apparition. The real place where that circle lives and its radius is defined is where? It's not in Maine. It's begins with a P. Person, indeed. In person. So if we go back to person, here's the oval, and there we see the fateful command. The radius is 10. How do we want to set it based on the age? Well, let's set it to be, let's say age. You'll notice it complains bitterly. It shows this little red X. It says invalid number. You actually can't do it there. What you actually have to do is the following. I'm going to change this back to 10. You actually have to change this thing to set dynamic value. Watch that. Ready? Boom. Okay. It doesn't have to make that sound on your computers, but yeah, I just changed it to depend on age, okay? There we go, age. How did I do that? I frobbed this little thing here. So I frobbed this, I changed it to a dynamic value, and I said, make it based on their age. Now I'm exhibiting pedagogical aches and pains. We're going to take it one step further. I'm going to say it's age in this person. It's this person's age. This oval is in a person. I'm going to say it's my age. I'm going to say this dot age. It's my age. This means me, and I'm saying it's my age. It's like my apostrophe age, but this is a dot. This dot age. It's my age. It's not his age. It's mine. Okay. So really, that was implied when I just said age, but it'll be helpful to be explicit about it for some of our later examples. So I'm going to say this dot age. Forgive me, but it may spare you pain later. Okay. Something parents have to say sometimes. Okay. Ladies and gentlemen, I'm going to set it to be age. Let's build this. Build. Let's run it. Run. As long as it built successfully. If it didn't, summon a TA. Okay, what do we see there? Ladies and gentlemen, what see us? Look at this. Person 1, person 2, person 3. What do we see? Yeah, and you'll notice the ones that are really big are what? Older. Yeah. So ladies and gentlemen, maybe that's a bit more variation than we want. Let's, instead of setting it to age, let's set it to the log. Let's set it to be, let's set it to be 2.0 times log of 1.0 plus age. You notice that I'm using these point zeros. That's not an accident as well. Sometimes you avoid problems by being explicit that you're using a floating point number rather than an integer. Java is finicky. It's sometimes tricky about that. And if you specify 1.0, you're clear that it's a floating point number, not 1. You'll spare yourself trouble. Okay. So I just changed this to be 2.0 times log of 1.0 plus age. And I put these in parentheses. Think of this as a little Excel formula you put in. It tells how to compute radius. When it needs it, it'll tell how to compute it. So now let's run it. Here we go. Boom. There we go. We get less variation. Who are these young, what are these things here? What are these really small ones? Those are kids. And these bigger ones are older adults. We have less variation because it's log scaled. Ladies and gentlemen, we've lent people heterogeneity and we've changed their appearance. But the fun, ladies and gentlemen, is just beginning. Okay. Yes? Indeed. This, for example, this one here? This one here, connections? Yeah, this is showing the population, and we could actually nicely separate that out. We could also tell it to hide it, not show it when we're running the model. If we wanted to do that, we could go in main, and we could select the population, and oh, no, it doesn't allow us to mumble. But in any case, we could make it not visible here in the advanced area. But we'll leave it there. Okay, other questions about this? Okay, so we have heterogeneity by age. Where did the age come from? Where did we specify their age? Why are some bigger and some smaller? Whence did that come? Anyone? Yeah, it was the uniform. It was associated with the population. Each population can specify the characteristics of the people within that population. Maybe we have a population representing Regina, another population showing Saskatoon, and we want to impose different age distributions on each. We could do so with two different populations. And then maybe sometimes people would migrate between them, for example. Readily done. Ladies and gentlemen, let's add in other characteristics. Let's go give these people something different, if we could. Let's give them a categorical designation, sex, okay? Okay. I'm going to give them sex. Now, there we go. We're going to drag in a parameter, and we're going to call it sex. Okay. Now, I hope that you'll forgive me by making this dichotomous. Just for the sake of this example, we'll assume it so. This is a sex parameter. How did I do that? I went to person, I went to palette, and I dragged in a parameter, and I called it sex. Now, the question is, what sort of thing is it? You notice it's saying it's a type double, a double precision floating point. That doesn't make much sense. Now, we could choose a couple ways of representing this. We could represent it as for example, a Boolean, with women, of course, being the truer sex. Or we could represent it as an int, with 0 being men and 1 being women. But there's a better option in any logic. And it's a nice option. It's a more transparent option. It's recommended by many benefits. And I hope that you'll forgive me for leading you through it. It's called, ladies and gentlemen, an option list. Okay? So to see this option list, we'll go back to projects. And this is another part of our modeling vocabulary. We'll right-click on this model, and we'll add to the model an option list. And the option list will be called capital SEX. It describes possible sexes, all possible sexes. Just like person class described all possible people, we gave it a capital P. This sex describes possible sexes. And I'm just going to say here, and I hope you'll forgive me, male and female. Okay. If you'd like to elaborate that more, you're welcome to do so. So capital SEX, we have male and female. Okay? There we go. Okay. So what we described as possible sexes here, they can be, we're saying male, female. I mean, we could say other. If you'd like to, you're welcome to do that. for simplicity, it'll ease some of our stuff in just a minute to only have 2. Okay, so we have 2 possible sexes. How did I do that? Ladies and gentlemen, I right-clicked on this. I said new option list. I called it sex, and I typed here male, and then I typed here female. I'm not going to do it again because I've already done it, and it's going to complain, potentially bitterly. But that's how I did it. Once more, right-click. I'm going to add to the model a new option list. I give its name here, and I type each of its elements there. The point is, this is a categorical, it's a category, and these are its potential values for the sake of this model. Ladies and gentlemen, now that we've defined that, we can go back to person where it says sex. This particular person's sex, what is it going to be? Well, it's going to be some value drawn from this set of categories. So instead of being a double precision value, an int or Boolean, we can drag it down and we can find sex. Do you see that? So we'll give them a sex, and it's either male or female. Okay? Now, I've introduced you. I've been stealthily introducing you to some features of AnyLogic here. We've got parameters. What's the job of this parameter? A parameter's job is to state an assumption and communicate it from the point of creation to the object that has that assumption. So age here and sex, the assumptions about them, where were those specified? Does anyone remember? They're specified on a per population basis. Where did we specify the age distribution? Where did that live? Is it somewhere else here in Maine that I specified age? No, it's in what? Maine. It's in Maine associated with population. If I click population, there we go. Here's the age, and now I want to draw a value for their sex. Now, there's many ways we could do this. I'm going to show you a different variant, okay, because it's one you'll use in empirically grounded modeling quite a bit. I'd like you to go to the palette. Ooh, I double-clicked on it. Didn't mean to do that. Okay, in the palette, under agent, there's a thing called custom distribution. Do you see that? Do you see that? Who needs TA help? The TA stand ready. Vigilant in scanning. Who needs TA help? Okay. TA? Anyone? Okay. Okay. So, ladies and gentlemen, I'd like you to drag in from a custom distribution to Maine. And I'm going to call it sex distribution. Okay? That'll be the distribution of different sexes in the population. We could have done this for age. It would be slightly more involved, and I didn't want to slow us down. We'll do it for sex just to show the principle. So the type here, for age it would have been continuous. For sex, which do you think it is? Okay, it's tempting to think discrete, that it could be 0 or 1, but it turns out it's even simpler if you say options, because then it lets you pick the option list. I'll say sex. Okay, so it says, okay, so basically what distribution do you want? And maybe I'll say, well, it's, 48% male and 52% female. Okay. So how did I do that? I went and I went over to the agent and made sure that's in the palette. I dragged in a custom distribution. I then set it to be a name sex distribution. I set it to be of type option, and I picked the sex option list. Where does it get these things from? Whence are those coming? Yeah, the option list I defined in terms of sex. And so it's saying, okay, what's the relative proportion of each of them? And I say 48 and 52. I could have just as easily said 0.48 and 0.52. It's really the the fraction of each here out of the total. In this case, it's out of 100 because they add up to 100. It could be out of 1 if they add up to 1. It's the relative proportion. Okay, now we're drawing it, ladies and gentlemen. This distribution allows us to draw a random sex based on this distribution. Do you see that? If we had done this by age, we could have drawn, instead of having a uniform between 0 and 85, we could have, you know, a staggered distribution where there's more younger people, and then successively, due to the deprivations of older age and chronic disease, there's fewer at older ages. We could have done that fairly readily. And in fact, the model I provided to you on your very site does exactly that. You can find an age distribution. But here I've just done it for sex. Now that's great. Let's go back to population. So how are we going to use that distribution? We want to say for this population, each person, what's their sex going to be? Well, all we do is we're going to say, hey, draw from that distribution. So we're going to say this dot sex distribution. Notice, okay, I'm doing something. I'm doing something of import. I'm doing something that is your friend. I'm doing something that you should do early and do often. I'm using a thing called, anyone want to complete it? Autocomplete. So ladies and gentlemen, I started to type this. I don't want to type this long name. I might misspell it. So what I'm going to do is I'm going to do on my computer control space. And unfortunately on Linux it sometimes shows this blank window over here, mumble. But if you do control space, it will show it on a PC. On a Mac, it's what? Option space. Option space, ladies and gentlemen. Do you see that come up? No? Okay. TA, sector 2, front, deploy. Okay, TA needed? Sector 1? Who else needs TA help? TA, front and center. So sector 1, sector 2, rows 1. Okay. Okay, ladies and gentlemen, to get it to complete, you need to start typing the name. So you type like SE, for example. Control space. Watch this. Boom. Oop. Control space, sorry. There we go. And the more things we type, the more specific it's going to get. So here's sex distribution. Now you'll notice it's giving me two choices. The first of them is the distribution itself. The second is a call to that distribution that's going to return, well, it says a double mumble, but it's actually not. It's a sex. So I'm going to choose the second one. Hey, come on. So it's the second one that I want. Okay. Now it's being finicky. Come on. Control space, and I selected it with my arrow keys and pressed enter. How did I do that again? Sex, control space, select with arrow keys, and so you can go up and down with the arrow keys, and I pressed enter. Boom. Done. What am I doing there? I'm actually calling the sex distribution. It's kind of like calling the sine function. You call sine with an angle, and it gives you back a number. Here, it doesn't need anything to do its job, so I don't have to give it anything, but I have to call it. I have to say, hey, compute something. Give me something from your distribution. And what's it going to give back? It's going to give back a what? Okay, don't put me in too much pain. It's going to give back a sex, okay? It's going to give back a sex. This sex distribution returns something from this option list, from the sex option list, okay? So ladies and gentlemen, I just called this distribution to draw a number from this distribution. Yep. Yeah, mumble. Yeah, I know. It shouldn't say that. You're right that it said that, and it's wrong to show that. It is an error, and it should be fixed. Yeah, it's wrong. You're absolutely right to object to that. And I objected too. I just didn't make too loud a vocalization of it. Okay, so ladies and gentlemen, and that's partly because distributions often return doubles and mumble. They probably just a hack that did. Okay. Okay, so now I can run it. And if we go down to the level of person, mumble? Oh, did I not build it? Okay, hold on. Build. Okay, I say build here. Each person should now have a sex and an age. Here we go. Okay, sex and age. So I built. I saw that it's happy. And I'm going to run it. And it sure is better be doing that. Okay. Mumble. Okay. TAs, note this dysfunction. The answer to, if you don't see sex there, there's an issue with any logic that 8.1.0 exposes sometimes. This is one of the motivations for 8.3.2. I'm going to close this model and reopen it. I'm going to say close, and I'm going to reopen it, simple heterogeneity. And now I'm going to build, and I'm going to run it. And there we go, and here we go, and mumble. Should be visible. Okay. Let's go look. Sex. Oh, visible. No. Good call, Wade. Good call. Okay, I had set it to no visibility for. I don't know what happened. I must have robbed it by accident. And I'm going to run it again. I didn't have to close it after all. It was just somehow I had messed it up. Okay, ladies and gentlemen, here's male and female, male, female. Do you see that? Okay, so now we have a distribution that's distributed according to that distribution, and an age that's distributed according to a uniform distribution. We could have done the same thing with age. Okay, let's give them a different color based on sex, shall we not? Let's give them a color based on their sex. Are we okay with that? Okay. Hearing no objection, we shall do that. So to have a color, I'm going to go up. Okay, this is a color for a what? Is it a color for Maine? Or is it a color for person? Indeed. Indeed. Could you refresh that? Yeah, thanks a ton. Ladies and gentlemen, it's a color for person. So I have to go to person. Where I want to give what a color here? I want to give a color to their what? To their, indeed. I want to give a color to their what? Okay, according to their sex, that's right. What do I want to color? I want to color their visual representation, which is this oval. To lend them a color, it needs to be in their visual representation. So, ladies and gentlemen, we're going to go to that visual representation, and you'll notice there's fill color. And I can choose these, but none of them seem to say, how do I do it by sex? But do you remember how I did this? What did I have to do here in order to specify the radius? So it wasn't just a fixed number that was specified. It wasn't just a set of possible choices, like a number. But I actually could give a formula for it. What did I have to do specially to radius to specify that? Yeah, I needed to turn it, I need to click this thing to turn it to a dynamic variable, okay? A dynamic quantity. Okay, ladies and gentlemen, let's now specify them to have a color according to their sex, okay? Now, there's a couple different ways that we could do this. One way is to use a wee bit of Java here. We're going to specify a formula, and it's going to be an if-then formula. If it's male, use this color. If it's female, use that color. I'm going to say if this dot sex is equal to male, I'll say double equals, maybe we'll say female just for putting women first. Question mark. If they're female, I want to use, let's say, yellow. Otherwise, I will use else. I will use gray. I always forget how to spell the color gray. I think it's EY. Is it EY or AY? It's EY? Okay, AnyLogic's naming is by the dictates of the American Imperium. So I think it's AY for that. And I build it. So what is this thing that lies before us? Ladies and gentlemen, I'm testing, is their sex female? If so, make them yellow, else make them gray. This returns a color, either this one or this one. If their sex is female, it will return yellow. Otherwise, in other words, if they're male, it will return gray. This is one of the reasons I want to keep it just to two sexes for now. There's ways to generalize this for arbitrary numbers, but it will get a bit messier. So that's going to dictate their fill color. I gave a formula for their color. Build early, build often. Building is your friend. Okay, so you do build model, and it says build completed successfully. That's a good sign. I would run the model now, and what should we see? What should be different? Speak on as if in a Greek chorus. Yeah, some are yellow and green. Which are the yellows? The females, and the grays are males, right? Okay, fair enough. Okay, good. Okay, now we're cooking with gas. Now I'm going to build on what we just did. We have heterogeneity of growing richness. Now I'm going to show an objectionable disparity, an inequity associated with heterogeneity. So, ladies and gentlemen, I would like you to add to person an income. We're going to give people an income. How would I do that? Who can tell me? Yeah, we add a parameter to person, don't we? Right? We add a parameter that's going to be called income. What sort of parameter will this be? Do we need another option list for it? No, we'll just treat it as a continuous parameter for now. So it'll be there. It'll be say a monthly income. Okay. So ladies and gentlemen, so we want to add an aspect of heterogeneity for the income. Where do we go add that to the model? Do we add it in main? Do we add it in the experiment? Where do we add it? Person, because it's a characteristic of the person. We're giving this person some characteristics, some properties. And we're specifying those with parameters. Those parameters are serving to communicate the assumptions about the person. They specify the assumptions and they communicate them from the point where the person is created in this population to the person themselves. So we're going to add another parameter. That's going to be a characteristic. Typically, parameters don't change over time. Later, we'll see variables which change over time. Parameters, typically something that you set and it stays that way. Ethnicity would be another good example. In some models, age will be fixed. Maybe it's a model of infectious disease spread or some fast incidents. We'll treat age as fixed because for the sake of understanding the infection spread, all we need to know is what age people basically are. For other models, like a life course model, their age should be changing over time. It'll be changing, like with a chronic disease. As they age, they might get a chronic disease. So again, models are specific to purpose. For some models, age, with very fast-moving things, age will be fixed. Other models, age will be evolving as an aspect of state. Here, we're going to add in a parameter called income. And it will be a double. Where do we specify our assumptions about income, and for that matter about age, and for that matter about their sex? Where do we specify that? Specified it in what? For what values to use for it? We specified in the, begins with a P, ends with an N, has a U in it. It's called, ladies and gentlemen, the population. Okay. So this is where we specify the assumptions. Remember that? So if we had Regina and Saskatoon, two different fine cities of this province, we might have different populations for each of them, and so we could have different age distributions, different sex distributions, different income distributions. Okay, now we're going to set the income here. But we're going to set it to be a draw from a log normal distribution. Now I could have picked this. Watch this. This would be an example. Here I can enter code. And I can go up to this distribution checker. And I could say, okay, I want a log normal. It's got to be 0 or more. It has a long tail on the right. I'm going to assume a mu, a log mean of 10.5. I'm going to assume a sigma, ladies and gentlemen, of 3.5. Boom. And sure, I'll assume a minimum of 0 or 3, but maybe I'll assume a minimum of 0. Oh, okay. Look at that. That's mumble. Okay. And I could actually say okay here, okay? And it will actually insert that. As it turns out, I don't want to impose a minimum. It kind of forced me in that way. But I could pick it, and you notice it inserted it right into here. It inserted it into this line. I'm just going to have 10.5 and 3.5. So that's going to draw their income from this long distribution with a long tail. Okay? Are we ready for that? Okay. Ladies and gentlemen, I want to be able to see that. Well, one way to see it is let's go build the model. Boom. Oh, look at that. Oh, it needs 3 parameters. Okay, this is a change. Okay, mumble. I'll do the minimum parameter as 0. So that's interesting. Ladies and gentlemen, a warning about any logic. The log normal distribution is sane. You have mu, the log mean, sigma, log standard deviation, and then minimum. In any logic, please be aware of a gross, I'm almost tempted to say atrocity. It's a shocking thing for those of us who work with statistical models. When you call a normal distribution, you have to specify the sigma before the mu. Don't get them confused. The first parameter for normal to draw from a normal distribution is sigma, and then mu, which shakes me, but they didn't ask my permission. Okay, so ladies and gentlemen, let's go run this model. Let's build it. Did you notice what happened? I changed this to this, and I built it, and it complained. How did I know what was the problem? Where do I go? So if I reduce this to 2, how did I know something was wrong? I went to build, and what did I see? What apparition stood before me? What black spot that begged me out? What did I see going wrong here? How did I know something was wrong? I went to build. I didn't see this friendly message down there that said it was happy. Right? I saw instead a red message, build completed with errors. Where do I go to find out what errors there are? Where is it? Here. It lies here. The method log normal double in type utility is not applicable for arguments double. Okay. That's geek speak. What it's saying is it's unhappy because I passed it arguments, this information it needs to do its job. There were just two of them. I passed it a double and a double. And what it really expected was three doubles. So I knew, oh man, they changed any logic to have to specify a minimum value. Bummer. Okay, so I put in 0.0. That's how I fixed that. And then I built again, and it's a happy camper. It said build completed successfully. So now I'm cooking, ladies and gentlemen, with gas. I run it, boom. And how could I know whether or not people are given an income here? How could I see their incomes? Can anyone tell me? I could go navigate down, right? Boom. Here they are. Here's a person with a very modest income. Here's a person with a more well-heeled income, right? Here's also another person, and here's a male with a high income. Here's a woman with of limited means. Okay? Ladies and gentlemen, how if we wanted to have their location be based on income? How could we do that? How if we want their location to be based on their income? Where would we go? Their X and Y. Okay. I don't know if you remember it, but we specified their location in the population. If we go to population, we'll see. Remember this X and Y thing? Remember that first encounter with these formulae? We've since used many formulae. These are formulas here. These are formulas. We've specified a formula for the color. We specified a formula for the size. And all of those, ladies and gentlemen, are nothing other than Java code. That's secretly this programming language Java. And they're calling off to functions like a sex distribution or uniform. Here, we want to specify their X location to be based, ladies and gentlemen, on their income. So what if I say here, how if I want to make it based on their income, not by itself, because the income could be huge, but income divided by 100.0. What do you think will happen? Well, actually, it's going to be unhappy. It says, oh, I can't find income. I don't know where income is. So you have to tell it, okay, in this case, my income, as it's setting up the agent, the way in which you say that is self.income, okay? Self.income. And now it's a happy camper. Now it says, okay, whatever my income is, which was generated up here, set my location, X location, to be based on that. Do you see that? Yes. Yes, and I'm going to actually link it to sex in just a minute. But same principle. Yeah. We could link income to age. There are several ways we could do it. We could add a table function, for example, or we could provide a formula with some error term as well as some deterministic term, some, that would, based on a regression, say, be capturing that association between income age. There's a number of ways that we could do it. I'm going to, for simplicity, show it as linked to sex, but if there were interest, I could pair you up with a TA and they could show how to do it for age in a straightforward way. Okay, ladies and gentlemen. Yes? Yes. 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 The explanation is an ugly one, but I will tell it to you, as I am bound to do. The explanation is this is extremely common throughout the models. In almost all cases, it's this. There's one exception to this, which we'll see again in just a moment. When you are initializing an agent, when you are setting up their properties, and you want to have some dependence between them. Say you want their income to depend on their sex, or income to depend on age, or you want their location to depend on sex or income. Or there, you're just setting up the agent. Here, you use self. Now, the truth is, I simplify a little bit because there's another case in discrete event modeling where you also use self to refer to certain characteristics of blocks. But the basic deal is for the core agent-based modeling, you just do it here. Okay? It's only here, and it's just as the agent's being set up. They don't even exist yet. So you can't say this to refer to them. So actually, you just refer to it as self. And there's a technical reason behind this that TAs could help you explore if you were interested. But fundamentally, it's because they don't exist yet. They're just being created, and this provides a way of dealing with the fact they're not fully born yet, and so we have to refer to what their income will be, that sort of thing. I wish it weren't so. Oh, they'll get created once you set their X, Y, and Z location, age, and then they're born. They get created with those characteristics at that time. And so I'm simplifying it a bit, but that's a good way to think about it. Okay? Okay, ladies and gentlemen, let's run this thing. Let's build it, boom, and let's run it. And here we have a description. Now, what's going on here? I'm going to right-click. What do we have here? Can anyone say? I mean, at a qualitative level, what's going on? Why do we have such a long distribution out here to the right? As we go further to the right, what are we seeing? Sorry? The rich people. This is the rich people. There's fewer and fewer of them. And they are very, very wealthy. There's probably more out there if I looked. Okay. Okay. So, ladies and gentlemen, we have a distribution by age. Let's make, pursuant to the comments here, let's make one characteristic depend on the other. Let's make their income, to capture the disparities we see in this population, unfortunately, let's make their income depend on their sex. We know that women are often paid for the same work less than men. So if I want to set their income to depend on their sex, we can do so with the following. Okay, so here we could say, and I'm going to put it one way and we'll see the problem with it. I'm going to say this dot sex is equal to male. If so, set it to be 11.0 and 4. Draw it from this distribution. Otherwise, for females, draw it from this distribution. And I'll set this to be 10 and 3. What's the problem with that? What's the issue with that? You'll notice it says sex cannot be resolved or is not a field. This is where we need to say what? Remember I said anytime you're in here, you say self. Self.sex, okay? So now I'm referring to my sex characteristic. By the way, which needs to be one above there. It needs to be already have been computed. Sex was computed before income, age was computed before sex, etc. Okay, so now it draws them from two different distributions, capturing the unfortunate inequity. Okay, ladies and gentlemen. There we go. Okay, now I'm going to go copy this up on the big screen. I apologize, I should have done that earlier. This is a little bit too big to fit on a line, so I'm going to do this. Hey, come on, boom. Come on, a little bit more, boom. There we go. Okay. So Christine has started to imitate my sound effects with computers. She tells me she's spontaneously saying boom in her office. Okay, so ladies and gentlemen, do you understand what this rule is saying? What is this rule saying? Anyone want to explain this? What is this rule saying? As we determine their income, what's the rule? If they're male, we draw their income from this distribution. Otherwise, in other words, they're female, we draw it from this distribution, capturing that inequity. Ladies and gentlemen, let's run this. And then we will have the final crescendo, and we will break to soothe your bodies. Okay? So ladies and gentlemen, we're going out here to the right. Do you notice the distressing disparity over here to the right? Well, it may not be obvious. It's dominated by men. Look at that. There's even a little Lord Fauntleroy, who is of minor age, but wealthy as Croesus. Okay. So in short, we have a disparity calculated. Okay. In the final little bit for this, I'd ask you to put in one more item that will show this disparity. Okay. And that's going to be a little bit of reporting. We have heterogeneity, ladies and gentlemen. We have several types of heterogeneity. Categorical for sex. We have age, continuous. We have income linked to the categorical heterogeneity. We place people in an environment, provide them a location. If the location depended on their characteristics, their visual location, color them according to their sex so we can see some of these patterns that might otherwise be hidden. But there's something we'd like to add, which is a little bit of statistics. We could export this, to be sure, but let's go to the population, and let's finally add in a brief moment of insight, we'll add in statistics. I'm going to go down to statistics. I went to the population. I went to the population here in Maine. I scrolled down to an area that was called statistics. If necessary, I unfolded it. I pushed the plus, and I'm going to say I want to compute something called male income, male average income. This will be a statistic computed over the population. What sort of statistic do you think it will be? AnyLogic provides easy ways of computing approximately 5 different types of statistics. A count, a sum, a min, a max, and an average. What do you think this will be if we want to compute the average? We could do it with a sum. We'd have to divide, normalize by the number. Instead, we'll do it with the average. We want to take an average. What do we want to average? Over what do we want to average? Well, we want to average over their income, because this is average income. Okay? Now, we want to do so. We want to average it over people, each person in the population. And if you look, there's a little light bulb that tells us how we say, for each person, how to compute their income. It says to use item. It says for the embedded object, but that's indicative of the person. So for each person, we'll call them item. And if we call them item, we get their income through item.income. And the condition for this is what? what would the condition be? If they are male. So if item.sex equals male. Okay? Okay, it's a little bit confusing, but the idea here is we go through each person in the population. Here's the first person. Here's one of Jeff's favorite parts of the boot camp. Here's the first person in the population. This is Jeff. This time it's on video. Yeah. So the first person in the population member 0. We call them item. We say, what's your income? And it tells us item.income. And we say, are they male? Yeah, I'm male. Okay, so it's going to include them. Now we go to population member number 1. So the next person at index 1. That first one was at index 0. Now it's index 1. We say, what's your item? We call them item. And we say, what's your income, item? And it says, my income is such and such. And it says, are you male? And I'm not male. Okay, we're not going to consider your income. Next person, person number 2. We call them item. We say, what's your income? I say, income.item. Item.income, rather. And we say, are you male? Yeah, I'm male. And so it considers that. So it takes the average over each for which this is true. So let's go run that. Let's first of all build it. Build. Boom. Notice this is a double equals there. It's actually testing, are these two equal? If it were assigning them to be male, you'd have a single equals. This is a double equals, okay? We're going to run it. Here we go. Boom. Ladies and gentlemen, there we go. Okay, so here we go. We see them operating. Where do we see our statistic? Well, if you click on the population, you'll see the average income. Oh, my gosh, for males. Okay, I guess this is Qatar or something, or Kuwait. It's $13 million a year, okay? Now, I want you to tell me, that's the male income. How would I do the female income? Can you tell me? By extension, how would I do the female income? I just did it for males. How would I do it for females? Well, I go back to the population. I add a plus. There we go. Let's have female average income. Let's call it female average income. Over what are we going to do the average? Well, first of all, is it an average? Yeah, it's an average. Over what are we going to do the average? Conduct the average. Over the, item dot what? Item dot income. Good. It's item dot income. And what's the condition here? Item dot sex, speak on, equals female. Good. There we go, ladies and gentlemen. Here it's computing it over females. It's computing the same statistic. This one only computes it for males. This one's for females. If we didn't put a condition at all, it would compute it over everyone. Here we go. There we go. There's the population. And so male income is 13 million. Female income is 1.3 million. Okay? Where is that listed? It's listed in the population. Why is it listed in the population? Because we associated that statistic here with the population. It's a statistic in the population. So, ladies and gentlemen, we created here a model which represented a heterogeneous population. We used that population to further show how we could change visual characteristics of how we display the population to capture that heterogeneity, both age and income. So age shown in the size, the radius, income shown in X, sex shown in color. We found we could have linked, we could have continuous characteristics like age and income, and we can have discrete or categorical characteristics like sex by using option lists for sex. More than that, ladies and gentlemen, more than that, we could have linked characteristics. So we could specify that, for example, their income is going to depend on their sex. Or we could specify their location, their X location depends on their income. So we lay them out in this way. More than that, we were able to add statistics which allow us to summarize over those characteristics in the population, over income here, statistics. We computed the average for all males of their income and for all females. If you wanted to do it for the whole population, if you just wanted to say average income, all you do is do an average over item.income, and you don't bother with a condition. There's no condition on it. It's unconditional. And if we were to do that, we'd find, okay, now we have an additional statistic here associated with an average income for the whole population. Yeah. Mm-hmm. Mm-hmm. Yep. Yep. Okay. Okay. Great question, and there's a good answer for it. Okay? So, ladies and gentlemen, what you're highlighting here is a feature of AnyLogic's way of dealing with random numbers, okay? So here we have an experiment. Do you see this experiment we've been running? Every time we run this, we've been running an experiment, right? And you'll notice each time I run that experiment, if I go look at this, I get actually the same numbers. That same exact numbers. It's precisely the same. Let's go see why that is. AnyLogic actually changed the default for this a couple of years back in ways that I have ambiguity about. So if we go to this experiment, we can go look at the properties of an experiment. Just like we could look at the properties, ladies and gentlemen, of an agent or of main. So let's go, or of characteristics in them. So let's go to the simulation, the experiment, the scenario, and we scroll down in properties, and you'll notice that it's saying randomness. Each time, do we use the same so-called seed, the same basic initialization of our randomness, so we get exactly the same numbers out, or do we use different ones, okay? If you say the fixed seed, it's going to say a fixed seed of 1. And if you use 1 and I use 1, and we have the same model logic exactly, you're going to get the exact same results I'm going to get. However, if there's even a slight difference, like you have a difference in how you define the distribution, it turns out the numbers will be drawing things in a slightly different way, and it's going to be slightly off. I'm going to set this, instead of being a fixed seed, I'm going to set it to a random seed. And what I'm going to posit is that each time I run this, I'm going to actually get somewhat different results. So watch this. I set this to a random seed associated with this experiment, and what that means is each time it's going to have different random numbers. So watch this. I'm going to do it with population. Here, the average income is $21 million. Look at this. Women, on average, only enjoying an income sub 1 million, and males, $51 million. Now, that's a society of objectionable characteristics. Let's run it again. Here we go. I'm running it again. Same model, also size 100 people. Here we have an average income of 2.2 million. We have males earning 3.8 million, not 50 million, but 3.8 million on average, and women 674. Let's run it one more time for good measure. The point is, each of these is yielding quite some different characteristics. Oops. There we go. And we'll try it this time. Here, males have an average income of $131 million, and women $651,000, with an average income of $60 million. There's a lot of heterogeneity here. And I think I will use this as a teaching moment, if I could, because I would argue that this variability we see is an artifact of something that right now has been hard-coded into the model. And what is that thing? What has been hard-coded into this model? The population size. It's a population size 100. There's quite a lot of statistical variability in that for a log normal distribution. Let's deal with a larger population. And you could say, well, okay, let's go change this to hold your horses. We have a better way to do it than that. Let's have each scenario use a different population size. That way we don't have to change the model out from under us every time we want to investigate a different size population. We'll just make it an aspect of the model parameterization. Ladies and gentlemen, when we had people have assumptions that needed to be communicated to them, their age, their sex, and their income, what construct did we use in any logic? What central construct did we use to describe those assumptions and communicate it? We used a what? Parameter. Thank you. We used a parameter. We communicated to the person what their age should be, what their sex should be, what their income should be. Suppose we want to communicate to Maine what its population should be. Who's going to communicate that? Well, to a person, it's going to be the thing that's creating that person, which is the population. Here, if we have a parameter in Maine, who's going to be communicating that? The experiment, the scenario. So we could have each scenario have different population sizes. All we have to do is to add to Maine a what? Parameter. We will parameterize Maine so it can be run with different assumptions about population size. And to that, we throw ourselves once more into the breach. So you go to the palette, drag from the palette into Maine, and say population size. Whoa, population size. One parameter to rule them all in Maine. What sort of parameter will be? Will this be a sex? Will this be a double? It'll be an integer, ladies and gentlemen. It's a count of things. And its default value, sure, if we don't specify anything for it, we'll say 100. But we'll have some experiments where we make it a lot more than 100, as we'll see. Boom. So what did I do? I went to the palette and made sure it's an agent. This agent type palette. I dragged in parameter to Maine, not to person, but to Maine, because I'm parameterizing Maine. I want different experiments to be able to tell Maine, hey, assume this population, assume that one. Hey, you assume a small one. This other scenario, I'll assume a really large one. The population size is an integer with size 100. Now, here's the population. What final thing do I have to do to use that population size? Anyone? Instead of being 100, what should it be? This dot population size. It's saying my population size. This guy here. Use it. Just like here I use my sex distribution. Here I'm going to use my population size to set the number of agents in this population. That's beautiful. Well, at least to my computational heart. Hearing no objections, I'll continue. So the local number of agents, or the initial number of agents, is population size. Later we'll see populations would fluctuate. Here we have population size agents at the beginning. Ladies and gentlemen, let's run it. Boom. Here we go. We don't see anything different. Why don't we see anything different? Because we're still size 100 population by default. This is 100. Let's now add a mega population. Can we add a megapopulation? Is that okay with people? Hearing no objections, I'll say new experiment. I'm going to say big population, okay? And I'm going to set this to be population size of 40,000. 40,000 people. So this experiment is going to be using populations of size 100, where we get a lot of statistical variability. With size 40,000, we'll get less small number issues, small sample variability. So I said a big population. How did I do that? I went up here, I said new experiment, and I set big population to have a population size of 40,000. Who needs TA help? The TAs sit ready to deploy for help. Help is needed in sector 2, row 2. Who else needs TA help? TA help is being summoned and ably delivered. Who else would need help? Okay, ladies and gentlemen, let's run it with the big population. Here we go. Boom. Okay, it's running. Look at that population. Do you see it? It lies before us. Look at that. Look at that. With the distressing disparity for the higher income regions, a distressing disparity in terms of the number of males compared to the number of females. The further we go out, the more males, well-heeled males are dominant. Okay, but ladies and gentlemen, I wanted to see those characteristics. So I'll run this several times. Here's big population. With big population, I will set this to, again, have this is key, a random seed. A random seed. What do you want me to show, Bryce? Here we go. In Maine, I have population size. I set it to be a default value of 100, but I added a second scenario here, which has a population size of 40,000. 40,000 for population size. That sets the value of this parameter when it runs the model. Who needs help? The TAs are deployed. Okay, sector 2, row 2. Okay, help is delivered. Okay, the cavalry awaits in the back. Tina, a modeler of formidable prowess, is ready to address questions. Okay, sector 2 is a hot area, hot zone, row 3. Okay, who else needs help? So, ladies and gentlemen, what did I do? I added to Maine a population size. I set it to be an int parameter. This is a parameter. It's going to encode what assumption we want to make about population size for Maine. I set it to be a default value of 100, but then I created a new experiment called big population, where I set that parameter to be 40,000. Ladies and gentlemen, parameters encode assumptions and communicate those assumptions from the point of creation to where they're to the agent in which they're embedded. For a person, their assumptions about their parameters are therefore defined, say, in the population, which creates them. For Maine, a parameter in Maine is the assumptions about it are specified within the experiment within which that agent lies. Okay, oh, sorry, that Maine agent is used. So the experiment specifies to Maine what assumptions to use for the population size. So the other thing I did with this experiment for population, big population, I set it to be here a random seed, ladies and gentlemen. I set it to be a random seed. So I'm going to run this and see what it is each time. I would argue there's comparatively less variability here for the average. by the terms of the central limit theorem. Here we are, we have a dense population. If I click here, the average income, for example, is 87 million, which is considerable and not shared by the instructor. Okay. You know, the male average income is 179 million and the female is 2 million. Let's run it again. Okay, there we go. Here we're running it again, and once again we click on this. Okay, here we get about 1.9 million for females and 103 and about 50.1. And I'll run it one more time. We are getting some continued variability, but it's somewhat less because of the large number of agents involved. Here the average is 44, and we again have 90.8 and 1.6. So we're getting comparatively less variability with 40,000. If we were to do more agents yet, if we had a different version of any logic and we did 1 million agents, the relative variability would be smaller yet. So what have we done here? We've specified, ladies and gentlemen, heterogeneity. Heterogeneity at the level of a person, linked heterogeneity of one thing, such as income, upon another, such as sex, linkage of appearance, location, to some of these characteristics of heterogeneity. We've further discovered we could use parameters which communicate assumptions, specify and communicate assumptions, also at the level of main. So by specifying a parameter main, we can have different experiments specify different assumptions to make, such as about the population size. We further discovered, through the helpful feedback from members of the audience, of the participants, that there's this sensitivity to our assumptions in the model in terms of randomness. And we have to choose carefully whether we want a fixed seed, so every time we run the model we get exactly the same results, or whether indeed we want variability each time we run the model. There's times we want both. We want reproducibility, we use a fixed seed. We want to sample from different particular realizations, different potentials, we use a random seed. Okay? Sure. Mm. Mm. No, same amount of time. Yeah. Now, when we are testing a model robustness of results against randomness, this gets to your question earlier, your prescient question. If we're testing how robust a model is to our assumptions, we will typically want to have some experiments where we use random seeds and we run it again and again and again and again, maybe 100 times, maybe 1,000 times. And we look at which of the outputs, exhibit empirical regularities coming out of the model and which are all over the map, or variability within that range. Just a bit of noise within a range that's clearly delineated. In which case, random seed will be used. We'll run it many, many, many times, and so it will take more work to get that so-called ensemble, that whole run, 1,000 times or 500 times or whatever. And that will be associated with more work. But for one run, they're the same cost. It's a great question, but it turns out they're the same cost. Okay? Thank you for asking. Yeah. Yeah. I'm going to show you how you can record it. And in fact, there's an AnyLogic experiment, if you want to see it, called SAR agent-based calibration, which has a parameter variation experiment, which if you run it, it will show variability. It will basically show, running the model many, many, many times, it will show bands in which the model results lie, and the variability lies within those bands. And you'll see, yes, there is variability between runs of the model, but it's variability within defined ranges that still leads to certain clear regularities between all the runs, even given all this variability in parameter values, for example, or in stochastics of the model, the vagaries of what people's income is drawn as or whatever. There's still these defined results that are very clear from the model. And that's actually a fairly common thing in dynamic modeling, that you might think, well, this model, if I make different assumptions and parameter values, can produce anything. No, it turns out the structure of the model, this gets to my question, to the question earlier. There's a lot more than data in these models. For most of them, there's structure. This is a particularly trivial model, which is more sort of statistical in terms of drawing things. But as we'll see in our next models, there's structure in them. And that structure implies behavior. It gives rise to behavior. And so in some models, the structure just dictates it will behave in a certain broad way. And yes, there's variability within that, but you can change parameters in a wide range of values, and you're not going to affect these broad regularities. So, or at least in broad ranges of those parameters, you're going to see the basic same features come out of it. It's just going to vary in a sort of in degree. And that's a notable feature of nonlinear models, that you see these kind of basins of attraction where you get sort of certain characteristic types of behavior. And often it will go towards a certain sort of state of balance with respect to that. Okay? Thank you very much. Any other questions? I think it is time to seek sustenance in the hallway. And I think I will ask, if I could, for case study considerations. I believe Wade, you're on the schedule, I believe? Yeah. And is that the Northern Waters case study? Yes. Yeah, yeah. And that will be contingent on UN's arrival. But if anyone would like, following the break, to undertake a case study, Wade will be presenting in S386, which is just down the end of the hallway to the left. It's a room that has a screen in there, and he'll be presenting an example model that was built for phenomena here in Saskatchewan under the guidance of Cheryl over here, characterizing aspects of the impacts of flooding on the functioning of northern communities, in disrupting the daily patterns and requiring remediation, say through delivery of water trucks, et cetera, which can carry risk of infection, et cetera. So if anyone would like to go see that, I would welcome you to do so. And we'll do that in that room down there, okay? And for those who would like to pursue projects, I'd also note that now is a good time to get started with a project. I've asked for some particular TAs to help out with projects. So after the break, those of you who are seeking either more lecture or project work, come back here and I'll specify particular students to work with the projects, and you can go off and do that, or you can take in some more particular lectures and have discussion on some of the material we presented, okay? Thank you very much, and we'll take a break for 10 minutes.